Hello Boomer Nerds and friends, this is the Boomer Nerd, George Tasker, and tonight I thought I would spend a little bit of time going back to the COVID virus data. It's been a few weeks since I've looked at it because there's been a lot of things happen. Amongst other things, I have rebuilt a computer and have had to spend quite a lot of time setting it up to the point that I am happy with it. Okay, so what I have just done is I've just grabbed the confirmed cases which went into the confirmed spreadsheet, and let's go and take a look and see how far out we go now. It's a long way out. Okay, so we're up into the C column. Or even up into the D column. Okay, so we are a very long way out. This is going to be very interesting to see what the end result is, because it's almost got to the stage I could ignore the Chinese data, because the amount of data across the world has just left the way that the Chinese data has been sorted out as a blip, a very tiny blip. Alright. So what I'm going to do now is I'm going to jump across to deaths. Oh, before I do that, I've just imported the confirmed data, and I would like to make sure everything is sorted by country. So I will do that now. Then we'll sort it. And it's all sorted in alphabetical order. It means that all the countries are together and the regions are in a suitable state. So we can now leave that for the time being, and we will head across. I notice it's still the American date format, so the functions I've built before to pass those numbers and turn them into Australian date format, which is necessary given that I am in Australia, have now been sorted, and we may rebuild those again some other stage. Now when it comes to spreadsheets, I am going to be building a spreadsheet on something entirely different, an actual work-based spreadsheet, and it's going to involve building up a spreadsheet roster from first principles, but that's something for the future. Alright, so we're at deaths. I'm going to get rid of this particular one, don't need any more, and we're going to open up the deaths. You might notice that they're all showing these files here .sql. This for the simple reason that I don't like the way it has been downloading the data. It's been downloading it as a so-called text file, and I thought, well, why would I do that when it will just come straight down as a .sql file, which is really just a table of some description. In this case, it's just a CSV table, and luckily the program is smart enough to detect. So we've done global, we want death global, so we're going to no, we don't want to select it, we don't want to right click it, go away. I just want to open it. Okay, alright, check the number of rows, whoops, 267, same as the previous one, so we'll have to make sure that we do the same here. It's only 264, so we need to put in another 3 rows. So we're going to insert 3 rows above, and now we are good to clobber the data that's here. But before I do that, I'll just go Control Home. We're going to jump straight out to the end of the data here, double D, yep. Makes me think of a bra size. Although if you spoke to Mark Rudolph, he said double D actually stood for dating and divorce. Okay. Here we go. Data's all in. We just make sure we're down at 267 rows. We are all good. And once again, I'm going to sort the data by country. Beautiful. Now the next thing we're going to do is go, actually we can probably just go back to A1 for now. There's a fly here in the room. If it comes around again, I'm going to go and get the bug killer. Right, go to the recovered tab, go to the home. Now this one had a different number of rows last time. I'm not sure why. It only had 250. So we're going to have to check that when we bring in the global deaths. So we're going to open it up. We want, hang on, no, it's recovered. Did I bring in deaths before? Yeah, I think I did. Find out in a moment. Here we go, recovered. If I get wacky numbers in my graph, so it's 253, so it's definitely a different number, but they have added three more rows to it, so we're just going to do that now. Add three more, insert rows above, and that gives me my 253. For some reason or other, when it comes to recovered, they've opted for less regions or whatever it is. Okay, so go across to the end, control home, and control shift and then press home. There you are. Gonna kill him. Missed. Oh no, I got him. Damn, I can't believe it. Alright, brought some COVID virus into the house for us. Okay, we'll see what happens. So I'm going to copy that, go back to my main spreadsheet. We're going to clobber everything that's in here. Then we're going to go to our double D's. Doesn't double D look absolutely delightful? So that's the 4th of May. How far out does this actually go? AMJ. Ooh, that's a double D. Yeah. Essentially the message is that we have a long way to go before we have to worry about U, B, W, X, Y. So, see, when you get out to this spot here, you're at the point of 26 times 26. I'm curious now, I'm going to look it up. Okay, calculator. There it is. Come here. How many columns do I have? 26 times 26. 676 columns. That would be 2 years worth of data before we got to the AAA. And then we've gone from AAA out to... Is there any easy way I can... So by the time we get to AAA, we've got 2 years worth of data. How many rows would that be? Actually, there's one quick and easy way to do it. Right. Now what we can do... No. Okay, we'll go 1. Okay. Can you see what's happening here? So we run it all the way across. Actually, this is counting it for us. Can you believe that? Now, is there a quick way to do this? There's got to be a quick way to do this. I know what I'll do. What did I do wrong? No, that's bullshit. Didn't tell it to give me a formula. Okay, let's fix it. Equals. Oh, there it is. There's our problem. Escape. So 1024 columns, that's interesting. So that's why they stopped at AMJ, because it's going by the count. So 1024 columns, so around about 3 years worth of data you could fit onto a spreadsheet. Okay, so there you go. I wonder if it's possible to put more than 1024 columns. Let's do a bit of research. Increase Libre Office spreadsheet beyond 1024 columns. So it looks like it's a hard limit. Looks like. Okay. How long ago was this done? 3 years ago? Increasing the limit of number of columns from 1024 to 16384. Somebody says look into using a real database instead of a spreadsheet. Well, most databases. What's this? Spreadsheet can be used in ways which go beyond DB table. For fields in a spreadsheet, a column can be just a matrix index. We can have multiple tables in the same sheet. SQLite's limited to 2000 columns by default. Highest number of columns you can set at compile time is 32k. Well, 32k would imply a storage number. Now, I'm going to run off down a rabbit hole here so that you can understand why there are certain limitations. So let's go and look at programming data types. And this is where things get rather interesting. So we're going to have to go back into a little bit of binary. Okay. Data types and programming. What's going to look the easiest? There's a few here. Look, I'll just take a quick look at a couple of these. See data types in Wikipedia. Wikipedia might have a fairly simple thing. I'll take a look at them and then I'll see which one will best show the different data types. Okay. No, not happy. Not happy with any of these. Int. No, not happy with that. Short, long, float. Okay. No, you're not giving me enough information. Alright. Because if this doesn't give me enough information, I'm going to have to actually create it for you. Okay. Oh well. None of this is easy. None of it. Oh dear. No. No. I want something that I can show my grandmother and that she'd be able to look at and understand it. I mean, I can understand all this shit. But I have to think about it, and I don't want to think about it. Here we go. Look at this. Talks about 16 bits in size. Okay. Okay. Alright. Okay. I think we can start with this. Okay. Okay. Yeah, right, that's a potential candidate for types. I think I like this one a little better. 1 byte, 2 or 4, and then 8. Okay, yeah, now we're starting to get somewhere. Now, some of this data has changed quite a bit in the 17 odd years that I've written computer programs. So we're going to take a look at the kind of data that you have. Now, as you might be aware, we are working with computers that think in binary. Everything that you get to see has a binary origin. Okay, going to take a quick look and see what they've got in the way of images. There we go. Alright. Here is one which can be quite helpful, binary numbers. Okay. So we'll just click on that. Pinterest. Oh, that could give us a bit of interesting stuff. Not enough. Log in to see more. Well, I suppose I better log in. Okay. All right. Now that's interesting. Okay. 727 by 767. I'll open it in a new tab, see what it looks like. Nope, not what I want. Open image in new tab might work. Nah, can't make it any bigger. Okay. Alright, so what we've got here is a couple of things. We're going to go back to this one here. Open image in new tab. Let's see what we've got here. Okay. Everything, as I said, is represented in binary. Everything. Now we can forget about unary. I don't know what unary is all about, so that can go away. Here it is. So we've gone in decimal from numbers 1 through to 15. And as you can see, 0 is done in 000. 1 has a 1 there. But then we want to go to the next number, being number 2. And we can only do that by rolling this one over to 0 again and then upping this to 1. And we keep doing this all the way down. Okay. Now, I have to remember, ASCII had a particular meaning. So we'll go back to here and see what ASCII, what do they call this? Abbreviation. There it is, American Standard Code for Information Interchange. That's what ASCII stands for. So what happened was a whole bunch of guys decided to get to and said, right, here's a bunch of symbols we need to be able to understand and have computers interpret, and this is the way we're going to get it to portray. So what that meant was that you could take a collection of 8 binary digits, and any combination of those 8 binary digits could be used to represent decimal digits that we could then understand. So if I put in the value 33, it's going to show the exclamation mark. And so as soon as the computer sees the byte with the decimal value of 33, which is represented by this 0010 and 0001, it will immediately spit it out onto your screen as a exclamation mark. And you can sort these either alphabetically or numerically. And you might have to ask yourself what's the difference? Well, I'll explain that in another video. In fact, I'm going to write down a little reminder for myself. Let's go in here. Why am I needing a sign in for? That's a bit annoying. Oh, it is in. Okay. So now I'm going to bring up my, not contacts, calendar. Bring up my calendar. And I need tasks. That's it. Now, so where's, oh, okay, tasks. Oh yeah, right. Okay, so today's date is the 5th. No, let's try that again. Want a task. Task is going to be why? Okay, maybe we'll do it for Sunday. Okay, so what was I going to do? I was going to explain the difference between sorting alphabetically and numerically. Actually, gonna get rid of that. No. Okay. And description. Now this is a little esoteric, so it's something you'll probably want to be and okay. Right. Okay. Right. So that'll, I'm going to move that into my to-do list later on. Anyway, so before I got so quickly distracted, okay, so we've got a whole bunch of symbols here, and these were agreed at the time by the people in the computer industry, which was really mostly America was the primary force at that time, so they're the ones that said, okay, this is what it's going to be. It's going to be 1 byte, and 1 byte can give you up to 127, which is that one there, 127 symbols. Now, of course, we could talk about the difficulty in dealing with international symbols, but right now that's way beyond our particular interest. So why am I banging on about this? Because we're trying to talk about the size of data. It, by definition, 8 bits of data make 1 byte. We'll go back here. Go back to where the data is defined, and I was explaining this because it helps to explain limitations. Now, as you can see here, they said it contains char bit bits. If you click on 3, so it gives you a specification. Right now, I can be pretty confident in telling you that char bit, whatever that is is going to be set at the value of 7. Limits dot h. Actually, we could probably go and look that up. Search DuckDuckGo limits.h, and this might tell us, there it is, char bit is value of 8. Now why do they say char bits, which is what we see up here? It says char bit bits is, so why do they say that it contains char bit bits? The simple reason is that at some stage they see a possibility in the future of changing this value. As soon as they change this value, then everything else associated with it is going to change. So char bit is simply the number of bits in a byte. And then they've got all these other things down here, and we will look at those as well, but right now not particularly interested. Okay. Okay. So the largest possible value for an unsigned character is 255. If we go to from 8 bits to 16 bits, which is this one here, and a multi-byte character, it's 2 bytes, which is actually 16 bits. The largest value can be 65,535. So why 1024? Well, it turns out 1024 is a multiple of 2. And as you can see here, we've got 1024 columns maximum. And as you can also see, we have some discussion about changing the maximum number, and you can see a whole bunch of conversation down here about the whys and wherefores of allowing you to go with greater numbers of columns. But for now, we don't have to worry ourselves too much because we've got at least 3 years worth of data. So why this? Well, it's fairly straightforward. Let's put it in. I know exactly why. So we're going to put equals 2 to the power of 10. So I need to put the power symbol in, and it tells you that that's 1024. I'll see if I can bring up the math symbols. Okay, LibreOffice math, there it is. Not sure if we're going to be able to do this right. Boolean and plus minus multiplication, division. Okay, I want operators. That's our problem. No. Functions. There it is. Okay. Power. There it is. So we're going to put in 2 to the power of 10 we got? Okay, no. So it must be, come on, put it back in. Oh, press controls there, that might be the quickest way of doing it. Okay. I'm going to blow it up so it looks a bit bigger. Now I have to figure out why we've got these question marks. So I'm going to get rid of that. Get rid of that. Get rid of that. And there we are. Alright. So there we go. We have 2 to the power of 10. And that's going to be equal to 2 times 2. Whoop. Try that again. Well, where's my multiplication? When do I need where's multiplication? Unary binary operators. I need multiplication. Tensor division. There it is. Multiplication. Two times 2 times 2 times 2 times, how many have we got there? Alright, we've got 5 there, we need another 5 more. Now I'm going to cheat a little here. Can I do it? Okay, going to get rid of some of this junk. And we're going to then there we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So what that means is that they, for some reason or other, decided that 2 to the power of 10 was going to be sufficient number of columns for the spreadsheet. Now we don't need any of that. I think it's 258. I've lost. Go elsewhere. No, not there, not there. Oh, maybe, no. Oh no, I went to a different spreadsheet completely. Alright, so I can blow that one away, and I haven't touched any in my, what's the name? So we've got, we need 10 bits of data to represent all of the columns. And so they've opted to limit it to 1024. Now, why they've chosen to do that, I don't know. I don't know what impact it has on memory. I'll take a quick look at the memory side of things. Okay, so we'll take a quick look and see where we are in terms of memory. Just take a quick look and see what have we got here. Memory in use. It says we're currently using 13 gigabytes out of a total of 31, so about 41% at the moment. Now it says memory composition, memory and process drivers or operating system. So what's this bit? Must be written as this before it can be used for another purpose. Okay, it's alright. Use compressed. Oh, come on. Yeah, nah, I can't be bothered with that. It just simply, the cost of trying to compress memory is the fact that you're going to put a lot more work onto the CPU. So you gotta take a look at the CPU. At the moment, it's running fairly steady. I don't want to drive it unnecessarily hard by having compressed memory, and I've got a bit of space to burn at the moment, so we're probably going to be okay. So so we'll leave that be for the time being. Alright, so I'm going to blow this one away. I don't need it to be, and I don't need this anymore. Don't save. We're going to go back over here. We're going to go and take a look at the charts, because there's been quite a bit of discussion about flattening the curve. Well, let's see if that is the case. Now I've got this chart maxed out to the largest possible point, so I'm going to see if we've got, yes, data ranges. Okay, so as you can see, we've got that, we've got Y values, and as we said, it was double D now, double D, and we're going to do the same down here, double D. Right, as you can see, it's continuing to look very much like the one we're seeing in the on the web page. So if we go back and look at the web page, here we go. Look at that. It's going up as a straight line. Now, I guess I'm trying to guess why that might be, and there's a number of possible reasons as to why it could be flat. Number one, and this is probably the one that's been trotted out by the media, is that they are actually succeeding in their efforts to contain the virus and, as they put it, flatten the curve. And I'm not going to be like some and deny that that is the case. I mean, it is certainly plausible, but there's other alternative explanations as to why we're seeing a flat line now as opposed to a geometrically increasing curve like we would have expected. And one of the reasons, possible reasons, could be to do with the amount of testing. If they are not producing enough testing kits, or the amount of testing is limited by other means, then we will not have a full picture, and the increases can only be limited to the amount of tests that it is possible to produce each and every day. So that is certainly a plausible explanation. I'm not going to try and put a tinfoil hat on all of this, but it is certainly a plausible possibility. You may notice that if we take a look at the African continent, there is not a real lot of infections showing, whereas a country like the United States is showing infections all over the place. Now that may be a reflection, and I believe it is, on the fact that at least in the United States they have a lot more testing kits, and they are probably putting their manufacturing to good use, developing more testing kits to be used on the population. Similar kind of thing in Europe. China seems to have died away at the moment, and I'm not exactly sure why. I guess it remains to be seen what happens there. They do have COVID obviously in other regions of China, so it'll be interesting to see what happens there over time. It looks like we're starting to get on top of things in Australia as well. Okay, so, but anyway, the point is that the curve here and the curve I've created on the spreadsheet, let me try and do that again, hang on. Now I'm getting pissed. here is looking no, not as close as I would have liked. I wonder why. This one shows an inflection point here. Shows 4 million. What have we got here? What's this number here? Let's go back. Okay, all right. I better do some investigation. Ooh, something weird is going on here. So I'm going to jump out, and we're going to go out this way. All right. It looks like I forgot to import the hang on. Let's go take a look at this. Ah, I know what the trouble is. I've forgotten to update all my formulas. Okay. Alright. Yeah, that one's fine. Yep, no, the data's all there. I've forgotten to update all my formulas. Okay, let's go and update all the formulas. Now, I'm going to do something like I did before. Click on this one, and then copy the whole thing out to double D. Yeah. Did that work? Something's gone wrong. Okay, let's try that again. We'll just do a smaller number this time. Yes. Okay. I'm not exactly sure what I did before. Okay. I know what I'm going to do this time. Okay, we'll say yes. Clobber everything. Oops. What happened there? DB. Oh, I know what happened there. Okay, so we're going up to DA. Okay. Yeah, DA. So that means I've got to go back and change my chart. Let's do it. Oops. We'll go data ranges, and it's got to be DA as opposed to DA, and this one DA. Okay, that's looking more like, okay, now we're seeing it the way it should be seen. Alright, notice how it went back to the old way, and this has to do with that bug that I mentioned once before. So we're seeing what looks like a perfectly straight line. So we're going to take a look at some of the other charts. So we're going to look at the global infections that don't include China, and we're going to do the same thing here. So it's going to go to DA, DA, and same thing here, DA. Okay, so yeah, no, it looks very similar now, so it's almost not worth bothering to look at anymore. Daily percentage infection increase without China. So we considered China at one stage to be rubbish, and to a large degree it probably still is. So we'll continue to ignore it. So I'm going to change the data ranges here. So going to go DA again and DA. Okay. Oh, look at that. So now you can see that our daily percentage increase has been declining across the world. So you could see right at the very beginning there are big swings, and that was to be expected because the numbers were very small, but now the numbers are getting really big. And this is a very interesting one, this particular date here. I wonder what it is. See if we can find out. Oh, what are we doing here? Okay. That's on the 12th and then on the 13th. So the 12th of March up to the 13th of March. Just going to take a look at those figures. So we'll run out to the 12th of March. Here we are. And then there was a big increase. I think there must have been a holiday on that particular day in terms of number reporting, and then they reported 2 days in the subsequent day, and that's why it got that appearance of being much bigger. If we had 2 days of reporting, if you average those two, it would have probably ended up looking a little bit like that and wouldn't have been anywhere near as exciting. Okay, this is where things get a bit interesting. We've had a number of countries compared in prior, and these were the ones that were the, what shall I say, early adopters of COVID. So we're going to put a DA into here and another DA into here. Oh, look at that. So that's South Korea. South Korea seems to have squashed the curve. Okay, so data changes. We'll leave it. So now we'll go to Iran. DA. Oh, Iran's still climbing pretty severely. DA. So is Italy. Australia's looking a lot less exciting. And DA. And that's Spain. How did they manage to get a drop there? They must have changed the way that they were assessing the dates or something. But look at that. So Spain, Italy, Iran. So what kind of numbers are we looking at there? 211,000. Okay. Now, the thing that they haven't told us is what kind of active infections are on the go there. And the way we're going to have to find that out is probably go in and take a look at their active infections. Anyway, we'll go in and we'll adjust this chart. This is a percentages chart. So we'll do the same thing here. DA. DA. Right, nice and flat. DA. And Spain, the last one. Okay. Now, what was I trying to achieve here? Percentage infected by population. Okay, so I went and grabbed the populations of these countries and then said okay. So right now, the highest population infection is 0.3%. Australia is the green one. That's the one that's been climbing by percentage. That's rather interesting. So let's try and just, oops, no, let's change that. Oh no, nowhere near as exciting as I thought it was. So they reckon they've managed to keep it at 0.02%, which basically means out of 1,000 people, 20 are being infected. Right. So what chart are we on now? We're on charts confirmed global. Alright, let's go and take a look at charts death. Chart death. Okay. We'll adjust the data ranges here again. And once again, we've run into formula problems. So let's go and fix the formulas. Let's go and fix them. Okay. Out to the end. We're going from BY going out to DD. Oops. I hate it when that happens. Pressing down the control key instead of the shift key. And we're going out to DD. No, DA. That's right. So, okay, we've got everything sorted. Let's go back and take a look at the graph. Okay. Alright, so there we go. We've got the number of deaths, $251,537. Let's go back and check the thingy. 251,718. Okay, so yeah, we'd expect it to be, yep, close enough. I will not do any further investigation on that one. Right, so let's go and update the next chart. Number of deaths per day. And if you take a look at this, you'll notice that it was climbing, and now the number of deaths per day is kind of, this is interesting. What? Is this a weekly cycle or something? Let's take a look. 19th to the 4th. What about this one? 26th to the 4th. 3rd to the 5th. Every week we've got a cycle. Wonder what we can make out about that. So this one was 19th to the 4th. Yep. Okay, let's go back and take a look at that. I'm a bit curious about that one. 19th to the 4th. day of week is that? Actually, let's go. It might be quicker to. We'll go out to the 19th of 4th anyway, just for the heck of it. Alright, 19th of 4th. We'll bring up the calendar. Go and take a look. 19th is Sunday. 26th, 3rd. Does this mean that there's less people dying on that day, or does this mean that there's less deaths being reported on that day? I wonder. So you can see, so that's a Sunday, that's a Sunday, that's a Sunday. Then you got Monday, Tuesday, Monday, Tuesday, Wednesday. What would this one be? 1, 2, 3, 4, 5, 6, 7. Sunday, Friday, Saturday. Yeah, but it seems to drop on the weekend, especially on the Sunday. And even here it seems to drop. During the middle of the week seems to be when it's, and this pattern seems to be establishing itself over a period of time. Being a global thing, I'm not sure that every country would be operating the same way, but there's definitely a weekly pattern there. I'd be very curious just to know why. But I guess we can find that out. Now, daily death percentage. I think, what did I work this out? Daily death increase. Okay, so the increase in death. So it can sometimes run into negative territory in this case. Alright. Data ranges. What's the time now? Alright, I better bail soon. I've got to go and see to the family. In which case we're going to have to do a second video. Alright, as you can see, because these others are 1000% and all that kind of stuff, I'm very tempted to take them out of the picture. Because what we're getting here, no, I don't want that. Cancel. See, minus 20. Oh, let's go and look at the numbers. This is not exciting. I'm very tempted to take out all these big numbers because, yeah, maybe I'll just zero them out. Yeah. Because they're just way too big. Look at that, 1,800%. This one here's a div naught. Don't you love div naughts? Let's go out to the end, and here you can see the numbers are up and down a little bit. So some days are bigger, some days are, so these are just compared day to day. So we'll say this is 20% higher than the day before. Now it's 10% lower than what it was this particular day, and then this one is 20% higher than it was compared to this day, and this is 27% lower than it was to this day. And so I guess the whole idea is you're looking to see if you can see more negatives than positives. More negatives means a lower death rate overall. Okay, so we'll leave that one be. Okay, so global deaths without China. Okay, data ranges, that one. DA and DA. Okay. daily deaths increase without China. Okay. So we'll do the same thing here. Okay. So this is a global thing. So at one stage it was up to 100% daily deaths increase. Now, so what was this one measuring before? Daily deaths increase global. And then this one is, oh yeah, no, this gets rid of a lot of the bullshit that was coming out of China. Okay, now take a look at that. It's showing that the actual rate is declining. Yeah, so it's smoothed out the figures. Now, death rate is something that we've been interested in because it was showing a climb there. So we're going to take a look now and just see, because it's been a few weeks since we've last looked at it. So we're just going to take a look here, DA and DA. Oops, what happened there? Exactly, what did happen there? Better go and look at that, because that doesn't look right. Sixth to the 4th, and then all of a sudden it's jumped to 100%. Is it really saying that we have 100%? Let's go and find out. Yeah, okay, let's go and take a look. So we're going to go to the 6th to the 4th. Why? BY3 plus charts minus recovered. Oh, what was this one? PX3 BY3 charts recovered BY. I know what the trouble is. We haven't updated this one yet. Okay, let's fix it. We will now update this one. Okay, out to double D. No, DA. And we should be able to go back to the previous one. We should be able to update a bit. And oh, look at that. Death rate is slowly starting to drop back. So we'll go up here, jump out to the end. 17%. Well, that's looking promising. Hopefully that means that the more vulnerable ones are the ones that are dropping out, and that now that they've gone, some of the tougher ones are copying the situation. Okay. Alright, so now we'll go to recovered, and I'm going to take a look and see what we've done here. Okay, oh yeah. So recoveries, data ranges, and the same EDA. Done. Okay. Okay, so yeah, recoveries is just trotting along. This is the one that I'm interested in. Current active infections. We've actually had to calculate these because you can't get the data straight off the numbers. We've had to, and this is why I like spreadsheets. Look at that. See, nice little formula there. It tells me how much more has been, how much is in the. So we're going to go up to DA. And we're going to click out of it, and it's going to. Okay, now interestingly enough, we now have, according to this, 2 million active infections. Is that right? Just jump out to the end. Yeah, 2 million and 3.5 million, so 1.5 million for which there has been a result. Global deaths. Why are you giving me that information? I don't want that information. Global recovered. 1.17. Yeah, okay. So in both these cases there is a result. And we said this. So if we subtract these two numbers, we should be around about 2.1 million. Yeah, 2.1, close enough. Okay, alright, I'm happy with that. It just seemed like way too high, but no, maybe not. Okay, recovered without China. This one's not going to look that different to the other one. We are going to put in DA and DA again. Click OK. Drag it down here. Jump out, back in. And as you can see, it looks moderately similar to the Chinese one. But like I say, we've opted to. Now, one of the things I'm going to look at before I call it quits for the evening is I'm going to take a look at the graphs we've created for Australia. Specifically for Australia, given that I'm into Australia. Here we go. So we'll do a DA here and a DA here. That is interesting. Now, if you look at, oh no, it looked like the curve was being flattened, but no, it is not being flattened. Take a look at that. It says we're currently sitting at 9,000. You see, for a while there it looked like it was being flattened, but now it is taking off again. What do we make of that? Well, I guess the thing we have to do is we need to start looking at some of these others. So daily percentage increase. So I'm going to take a look at that. We can also start looking at recovery rates for Australia. So I'm going to have to work out how we're going to do that. In fact, I might take the time to do that before I toss it in. Okay, DA and DA. Gonna click OK, click outside, move it around to update the data. Alright. Okay, I'm just going to jump out here to the end. You know, I forgot to check to see exactly where we're at. Ah, okay. I see what our problem is. Right. So we're going to do a column thingy. Okay. Sorry guys. No. Oh, come to Papa. Gonna run out to DD. And that's going to clobber everything. And then we'll see if we've got any better looking data. Well, there you go. So we have flattened the curve. Oh, so much for my concerns. Okay. Alright, so according to us, we have flattened the curve. Then, what about here? Yes, it's getting down close to 0% in terms of actual growth, so that sort of confirms it. Now let's update these numbers here. Data ranges. Okay, it's continuing to climb. Daily deaths, let's do that. Okay. So the number of deaths in relation to the number of infections looks fairly small, because this here is a cumulative total, even though the numbers look bigger. This here is a daily number, and as you can see, there are even some days in which there are no deaths. For example, let's look at this one here. 18th to the 4th, 23rd to the 4th, 26th, 27th, 28th, 29th. Okay, no real pattern there, but across the globe there is a pattern. Okay, I'm going to stop for now, because there's certainly lots of other data we could look at, but I think I can call it a night, and we'll take a look at the rest of the data in detail next time I put up a video. So this is George Tasker, the Boomer Nerd. You guys take it easy. Good night.